kiddos, and welcome to the lab. So today we're going to do investigation 11.3, applying Hess's law. And we're going to use this, the concept of Hess's law, and our friend the calorimeter in order to figure things out. So the question in the lab, you should have your lab with you because it's there for you, is what is the standard molar enthalpy of combustion for magnesium? So this is our question. This is what we're going to try to figure out. And we're going to do that by calorimetry and the concept of Hess's law. So this is what we're searching for. We're searching for the enthalpy change of combustion first, and then we'll find the molar enthalpy of the combustion of the magnesium. So this is what you have to build with Hess's law. This is in your lab write-up. And what we have to go with is we have 3 data points or 3 pieces of evidence. The last piece it's given to you, we're looking at the formation of water, liquid water, and we're also having to use our calorimetry, our knowledge of calorimetry, in order to find the delta H for each of these. So the first one is magnesium oxide plus hydrochloric acid is going to yield magnesium chloride plus water. And then the second one is magnesium, for that we use a magnesium strip, plus hydrochloric acid is going to yield a magnesium chloride and hydrogen gas. So without further ado, let's go and get this done. So what we're going to do is we are going to measure out the magnesium oxide. Once we use our scale, we find that we have 0.5, where we're supposed to have 0.5 grams of the magnesium oxide. With that, I have the initial temperature, which is about 20 degrees, as you can see, of 25 milliliters of the HCl. So that's going to go in here. And then along with that, I'm going to add 0.5 grams of magnesium oxide. And we're going to stir. Oops, we're going to put the lid on really quick. Because now it's an insulated system, right? Perfection. Fancy calorimeter, insulated system. And we're going to let that do its magic.
I'll stir it.
Oh, you can stir it if you like.
Well, then you can do the other one.
Okay, and then we're going to have a stir.
Off screen.
Okay, off-screen stir. Now, the next one is we have a magnesium strip. And what I've done is I've used some sandpaper.
By the water bottle.
And I have scraped the barnacles off the magnesium strip. I'm going to place that. And there's 0.10 grams of the magnesium strip. And I'm going to place that in my calorimeter. Along with that, I have 35 milliliters of hydrochloric acid. For some reason, this one starts off at 21 degrees Celsius. So I'm going to go ahead and add that.
What did this one start at?
The other one started off at 20 degrees Celsius. I'm going to cover.
I like this concept better than stirring.
Oh, she's going like this. Dagmar's doing this instead of actually stirring with the
It's
thermometer.
working.
Because you're not supposed to stir with the thermometer, you're supposed to stir with the stir stick.
Good point.
Right? So, we're going to let some chemistry magic happen. Right? And then we're going to take the final temperature. But before we take the final temperature,
This one's not moving anymore, so it's probably good, right?
I have just our table of data. And I have the reactant, magnesium oxide, along with the mass of the magnesium oxide and the initial temperature of the hydrochloric acid. And I also have the magnesium strip, the mass of the magnesium strip, and the initial temperature of the hydrochloric acid. So we're going to let this react.
Give me that one.
And this one is bubbling, so it's probably
Should
not
I stir
finished.
it?
Yes, we should stir it.
I'll just do the same thing.
Okay, she's just doing this.
Like this kind of stirring.
That kind of stirring. And we can see that, and what happens is you just watch for the temperature change, until it stops changing, obviously. And then you're going to,
That one's been between 31 and 32 for a while.
okay, so I think we're done.
I think
so
it's
this one's
done.
probably 30, I think it's 31.5.
Yeah, that's what I was guessing, but I
Yeah,
wasn't sure if you
so-
were doing the point system or not.
Yes, 31.5. So I'm gonna write it down for the, and this is the magnesium oxide, 31.5.
Ooh, this one's higher.
Celsius.
This one's at 34, just about 35. So I think I'm just gonna keep going.
Yeah. So right now I've just put in 31.5 degrees Celsius. And then when I get the next temperature, I'm gonna pause the video and I'm gonna come back and show you all the work that has to be done. And hopefully it will all make sense. Okay, kiddos? So hang tough for a couple of minutes. And then I'll pause it once I get the change in temperature of the magnesium plus the HCl.
Should it smell,
Yeah, I think
the
so.
reacting?
Yes. I
'Cause
think
it-
you're smelling the hydrogen gas.
I'm smelling something.
The hydrogen. If we collected the hydrogen gas,
We
we can
could go-
actually we can actually collect it and then do the test for the hydrogen gas and make a really cool popping sound.
But we're
Explosive.
not gonna
But
do that
We're
because
not
that's
doing
dangerous.
that. Danger. Danger.
Especially with us.
Yeah, danger.
Okay, this one's stopping.
Stopping.
So, well, it's stuck at the same temperature.
Because what happens is at some point the magic is over and then we have to just take the data and
Wash our hands because we spilled.
yeah, if we spill we wash our hands. And we have a temperature, ooh, 35 degrees.
Yeah, it was pretty
And I don't
consistent
think I
there.
hear the bubbling. Let me just take a boom.
Oh.
Oh, the magnesium ribbon is gone.
It
So
disappeared.
it's all
Magic.
reacted with the HCl. True
And-
magic.
Chemistry magic.
Chemistry magic happened.
Oh.
So I'm going to take the final temperature,
Oh,
which is 35 degrees Celsius. Okay, can you pause the, can you just stop the video?
I sure can.
Thank you.
How do I do that? Push that record button again?
Yeah, I think so.